let's go on to project number 3. Remember the number of your project for your favorite for audience choice. So this project is, I believe, BLIMI, BLIMI, Blockchain in Medical Information. And presenting this is Lindsay, Mike, and Kathy. So I will turn it over to you.
All right, thanks, Brad. Good afternoon, everybody. Again, my name is Lindsay Marrero. I'm also here with Mike Ciancibello and Catherine DeKoski. We will be presenting the project BLIMI. I don't know about you guys, but we've had an exhausting and fun last couple of days, and we've learned a lot. So I'm here to share what we've learned with you guys and the project that we've come up with. So give me a second, I'm going to share my screen. Okay. Again, the project is BLIMI, as in crikey. And it stands for Blockchain in Medical Information. I don't know if I mentioned this, but all three of us are software developers at the Cleveland Clinic. And if I can advance here, okay. Okay, so I'm going to kind of take you through this journey that we went through. We started this project with really no idea what blockchain was, no idea what Ethereum was, other than maybe a little bit of basics on cryptocurrency. And we really wanted to, we had heard of applications in medical imaging and in medicine in general of blockchain, and we really wanted to investigate those applications and learn more about blockchain. So what is blockchain? It is a globally shared decentralized transactional database. Its main purpose is to synchronize states and history of transactions. It's a ledger of sorts. And its main benefit is it prevents fraud. So if you've got a chain of blocks and each block is a transaction, none of those blocks can be changed historically because it would invalidate all the following blocks going forward. So it's pretty secure, it prevents fraud. So our scenario that we kind of wanted to tackle here was, say you have one patient that travels between multiple healthcare systems. And let's just take, for example, problem list. That patient may go to health system A and have a problem list, have a diagnosis of diabetes. Then they go to healthcare system B and they get eczema added onto that problem list. Healthcare system C, you kind of get the gist here. They get hypertension, and then healthcare system D, maybe diabetes and hypertension have resolved and they are just left with eczema. And this patient goes back to the originating healthcare system. And all that health system sees in their EMR is that the problem list for that patient was diabetes. We don't have an idea of what happened in between those 2 points of time, if anything. So imagine you're a doctor or a physician and you want to know, what are my patient's current problems? And again, we're assuming no shared EMR. And how can we tell that there have been changes to their problem list between those 2 points in time? This is a really good implementation, I think, of blockchain. So if you can envision this, each account is a patient, and a patient can register their account kind of like I don't know, maybe an online portal, or kind of like how you would let people know your social security number or something along those lines. You have a unique account number. You have to let those health systems know that you have that account number. So that patient would register that account number with each health system. And then blockchain would keep track of each transaction in a block. And as this person travels around the healthcare systems, the blockchain gets updated with the most recent transactions. So the block number would be incremented at each change. And then at the originating health system, you can ensure that you have the same as the latest block on the chain. And if you don't, you know that there's been some mismatch. And again, to illustrate this, you've got block 1, 2, 3, and 4 representing 4 different transactions. And you get back to the originating healthcare system, you're still on block 1. There's block 4. You know that there's a higher block number out there. So you have a block mismatch. You know that there have been changes between 1 and 4. So our implementation, we utilize the Hackathon Ethereum server. We created a smart contract for patient definitions and methods using the Solidity programming language, which we had to start from scratch learning. It does require an initial amount of Ethereum currency to run the transaction. And we compiled in an IDE called Remix, it's online, to obtain an ABI and bin file. And then we feed those 2 files into the Ethereum API service and get block information for patient accounts. We also utilize the FHIR API service so that we can get discrete elements from the FHIR API service and compare it to what we have in the Ethereum service. And we created an MVC.NET Core application that accepts a patient ID input, calls each service, and displays the appropriate output. I'm going to flip over to our demo. Mike, if you're there, I think he's going to talk through our demo for us.
Hey, Lindsay, can you hear me?
Yep.
Great. All right, so like Lindsay said, this is our demo .NET Core application, which allows us to query both the FHIR API and the Ethereum server pretty much in real time for a given patient. So for this example, we'll search for SIIM Ravi, and then we'll click validate. So when we click validate, first we're going to send a request to the FHIR server with the provided patient ID and display the patient demographics from the response. So that's shown in the first box below. So we're displaying the patient name, gender, and birth date from the FHIR server. So next, and you can see this is already completed, but we issue a request to the Ethereum blockchain network to retrieve the most recent transaction and block number for the patient's registered account ID, which you can see there in the Ethereum response. So the data that's displayed in the table below was retrieved from a smart contract that exists on the blockchain. So specifically for this example, our smart contract tracks information about patient encounters and the problem lists over time. We queried the most recent transaction. So you can see we have 4 items in the problem list as well as a transaction count. So the transaction count displayed, what Lindsay just highlighted, displays or represents the number of transactions that have been processed on the blockchain for the current account ID. And in a future version of this application, and if we had more time during the hackathon, ideally we would like to show the full transaction history, or maybe the most top 10 most recent transaction history details for a patient and their associated smart contract data. As well as deploying additional smart contracts to the network to track and validate additional information. And I'll turn it back over to Lindsay.
Sounds good. Thanks, Mike. I know if I hit F5, it starts me from the beginning, which is what I don't want. Hold on, sorry. 2 years into a pandemic, you'd think I would have this down. Okay. All right. So as Mike mentioned, if we had more time, so I will mention we spent 2 days trying to get a good, solid Hello World application to work well. So we did run short on time on things that we wanted to do, but I think we got through a pretty good proof of concept, but we'd like to do more. I mean, and I think I speak for the 3 of us where we learned so much, but I felt like we learned a lot, but you almost walk away with more questions than you got answers. So definitely this is something that we're really interested in keeping going and seeing what we can do with it. So for next steps, what we'd like to try to do is to traverse blocks and get transaction history for an account. It would be nice to see that, see things added onto a problem list or removed from a problem list or whatnot. We would also like to run our own Ethereum node and process work. Right now we were relying on the Hackathon server, which was fine. It just, it would be nice to be able to issue commands and all that ourselves. We'd like to define and store additional smart contracts with logic And in the UI, we'd like to denote what data elements have differences, so have a tighter integration with FHIR. Lessons learned, again, we started from square one. What is blockchain and Ethereum? Spinning up a test Ethereum network is a non-trivial task, we figured out. We thought we could do it ourselves, and within the next 2 days, or within the last 2 days, and there just wouldn't have been any time. We are now familiar with the Remix IDE, the best ABI and bytecode files. We first tried using Visual Studio Code and it did not work very well. We learned about the concept of gas in Ethereum and we got so many errors. So we used a lot of troubleshooting skills and debugging to figure out what the heck is going on. And other use case ideas, I mean, we got so many ideas from the community, the hackathon community. We would have loved to collaborate with some domain experts and work on some of these some more. But again, it took us 2 days to get through a Hello World application. So if we just had more time, we would have been able to look at things like vaccine verification, doctor credentialing, anonymization keys of DICOM, tracking images used in machine learning and model training. All of these are really great ideas. And I would have loved to have been able to dive deeper into those. And with that, we'll take any questions. Thank you.
Thank you, Lindsay. Yeah, questions from the judges.
Sure.
So it's not so much a tech question as maybe a domain question, but had you thought about discrepancies with the problem list? So because all of the data behind the list of problems isn't, of course, put into the blockchain, if hospital B says, well, they don't have this condition that hospital A said they did have, it may just be that hospital B has a different opinion or doesn't have access to the same data. And so when there's, you know, when something is getting added and subtracted, kind of, I guess, how this might work in practice. Any thoughts on how discrepancy resolution might get mediated or work out?
You know, in my opinion, I think I hate to introduce more standards, but standards might have have a good play there. You know, I mean, everybody would have to play by the same rules and, you know, have some kind of standard on how we store data and let the blockchain know that there has been a change.
And I guess maybe part of it, you said with the transaction history, you could see who's removing it and who's adding it. And maybe that says, okay, well, you guys are disagreeing. You need to go take it outside and work it out.
Exactly. Yeah.
So you could find out who's got the conflict, I guess. Yeah.
Right. Yeah.
I would have said that that's a strength of this approach, is that oftentimes we have no idea when things were added or dropped in our current environment, right? And who did it and when.
Right.
So I actually find that this is a phenomenal application for exactly that reason, because of the discrepancies and the issues we come across with errors. Yeah.
Yeah, one other thing, and this is kind of thinking a little bit outside the box. In a blockchain-like scenario, you could actually use a system like this to deploy what's called a DAO, a patient record as a DAO, distributed autonomous organization, in which the participants are the individual hospitals and perhaps the patient themselves, so that these conditions the dispute resolution essentially comes down to either a vote or some sort of weighted voting. Is another way to go about it. I do have one question, if there is time. Sorry, Brad, how do we do?
A quick question, go.
Okay. Is it true that based on the implementation concept here, it appears that it's an all or nothing kind of implementation? In other words, the patient, so all the hospitals that the patient visits has to all buy into the same blockchain, or
yes.
that patient's record would not work at all. I can't just go to 3 hospitals and 2 of them are part of the blockchain, the third one is not. Is that true?
I think so, because yeah, if you have a hospital system that does not play into it, I mean, you could have just missing history, you know. Yeah, I would agree. It's probably an all or nothing, unfortunately. But hopefully, you know, everybody would see the benefits of doing something like this, and it would be an easy sell, right?
I would almost argue that the patient owning this, the decentralization of the record would actually be the advantage there, right? So that you wouldn't have to rely on the hospital systems to play. Like you are in control of this, right? You have ownership. Yeah.
Yeah, I love the idea of enabling the patient and empowering the patient to have that data.
Okay, thank you so much. So that was project 3, BLIMI, blockchain and medical information.